thank you very much, and thank you for sure for the invitation. I'm pretty happy here. It's my first time in Bulgaria. I'm very curious about what is going on in every single country in Europe about open science. And I was very happy to discover that Milena is involved in this amazing project, that you are getting deeper in something that I like very much, which is the open research and innovation. Because responsible research and innovation is too short and open science is too short. So you merge two concepts together, ORRI. I think it's very clever and very intelligent, because the element of the responsible research and innovation, just focusing on the 2015 approach on open access, it was too narrow, in my opinion. So I think you are in the right context. But what I'm going to talk about today is about fair data, which is one of my current research topics in the Open Science Lab. I always say that when people ask me, why are you so involved in open science? And I say, well, because my thesis was about metadata, and the metadata took me to open science. And now open science is taking me back to open data and to metadata, which is the core business of fair data. But I wanted to just point it out, what is the fair data, just in the context of the skills, because I'm also a member of a Skills for EOS project. I'm engaged more or less in the PhD and early career researcher training. I'm very much on training new generations, but I think at least every single researcher in the 21st century has to have a clue about fair data. The point about fair data is that, okay, but how much points do you give me if I get a skill up in fair data? I'm rewarded to publish papers. What's the point about making data fair? So that's why I want to contextualize fair data in two contexts. One is the responsible research evaluation, and then also the fairness that you have to know a bit in your own domain to have a skill to make your data available. I'm very happy that Professor Peter and also Milena made a big overview about what is open data, what is data science, what is the new science that is based more in algorithms, in more high performance computing and these kind of things. But at the end of the day, we need to have a minimum viable skill set, as we say in a Skills for EOS project, knowledge on fair data. But I'm always says that FAIR is a happy acronym, like laser. Do you remember what laser stands for? No. People just keep saying, and we will keep saying fair, 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 and at the end we will just say a big word that is very fashion in the context of EOSC. But saying findable, accessible, interoperable, and reusable is very easy. To make data fair is very complicated. It's very complicated, it gathers a lot of technical issues, and sometimes not every single researcher is prepared to make their own fair data, their own data fair. So that's my context and my caveats. Those are the pillars that Milena mentioned this morning, the pillars from the UNESCO declaration in November 2021. But those are the pillars that the Commission put us in the Open Science Policy Platform that I was the chair at that moment. And fair data and EOSC were two of the main target issues on open science in Europe. But also I want to tell that this is just in a transversal way. It's not only for one kind of a stakeholder. The fair data and the European Open Science Cloud should be target points of the European policy on open science for every single institution, every single stakeholder, including libraries, including their own researchers. Because sometimes we say, well, fair data is something that will happen in the library, or fair data is something that will happen in the data steward, and it's not about myself, my research. So that's practicing open science is something that the researchers we want to put in others' hands, but it's a commitment of us. And another issue that I wanted to point out is the rewards and incentives. For example, I'm pretty much involved in an initiative that is called Make Data Count, which is run by DataSide, and also the REA, the the Research Data Alliance has a working group on research data as making data count in the context of research evaluation. If you don't give me any credit to make my data fair, there is no point to make your data fair. Yeah. Of course, we have the trade-off of the grant agreement or the money that we get out of public funding, okay? So what is the Horizon Europe? What is the framework program in Europe? It's a bunch of money, it's a bag of money, and I decide how to bring it to you. And you know, when we apply the golden rule, and the golden rule is who has the goal puts the rule. So the point is that the Commission said, if you want this money, would you like to have this data set? Would you like to share your data? Okay, you have to do it because it's a requirement to give you the project funded. So that's the only thing, the only motivation that we have so far. Luckily, in Coara and in some of the working groups that we are working on making valuable data, it is more and more working on that principles that they make data count. But let me just have a bit of background. I think the background of the data was very much established this morning with the previous two presentations. But just let me think about what is going on in the data landscape in the last 10 years. We just came from the big data, when big data was the buzzword, and now the data are really big, but really, really big. So we have been just changing from the USB and the local storage to the cloud computing and the high performance computing. All the governments are having open data policies and platforms, and also we are increasing the computer power. But the main shift in the last 10 years is that we are trying to, and I say we are trying because I think we are on the way to do it, we are trying to make data and software as first-class research output. And just a big reflection in brackets. What's the point to make papers in 3 years' time when all the artificial intelligence and generative artificial intelligence can produce a paper? Producing a paper is not amazing anymore. What it is really amazing is producing raw data and the real data that can found the paper. If we keep doing only the focus on the paper, we are losing the reproducibility, which is the real thing of the science, make science reproducible. But we are making a machine of papers, and all the reward is made of papers. So to make software and data as a first-class output is crucial to have a development. Because we can't just have ridiculous situations that you create a software that make a revolution in the world, okay? So you're a computer scientist like you in your research career. You create a software that has a revolution in whatever field, in the administrative field or whatever. But you don't write a paper about that software. You are a screw out of academia. So what's the point of making a paper? The point of changing the world. So what happened with the data is exactly that. And fair data is just a kind of not only data, but quality data. Fair is a synonym of quality. And of course, we have millions of developments that are coming up in the data context, in the data science, in the data as a main output, and in these kind of approaches that we need. And this morning was also mentioned the research life cycle. What it is in the research life cycle related with open science is that we change the way we open from the beginning. In the current research system, in the closed research system, we only share at the end. We only share when we have all the paper perfectly done. But the main point of the open science is sharing as much as you can, as early as you can. For example, if you can share your ideas, you make your pre-registration, share your idea. No, but if I share my idea, somebody can copy it. What better protection of sharing it that says your idea? And share the idea to have a collective access. Somebody can collect this data, somebody can analyze the data. So the point is that open as much as you can and as soon as you can, because it will be a way to have a feedback on your research and a more qualitative, more coordinated research. So not only papers, but also opening up data, methods, and code, and applying FAIR principles to all these outcomes. I don't think I will have a lot of time today to explain in deep what is the FAIR by design methodology that we applied it within our project in a Skills for EOSC to the open educational resources or the educational resources or the outcomes of the research training. But also FAIR principles are applied to the software. And FAIR principles are applied. Last week I was reading one of the deliverables on the semantic artifact catalogs, and they are also applying FAIR principles to describe ontologies and vocabularies to make the data fair. So FAIR is kind of a happy acronym. Learn about FAIR, and you can speak about that in Christmas dinner. So this is very fancy to do it nowadays. So what are the challenges that I see in this context of the data, in this new open, responsible research and innovation and responsible research assessment? The two things, I think that open science is becoming RR whatever, responsible research and innovation, RRI, responsible research assessment, RRA, and also retention, right retention strategy, RRE, is all RR things. But what is the real challenge that I think that is in the context of open and fair data is to make fair data as a reward element. The more data you share, the more fair are the data, the more credit you get for your academic career. This is the only way to make it. And also to connect fair data with good data. And connect good data is connecting with good metadata. At the end of the day, it's all about a strategic standardization in terms of metadata, vocabularies, and standards. It's all about the standards, but think about this. FAIR is not a standard. I hate when people say, this is FAIR compliant. No, to be compliant, you have to be against something that is technically a standard. FAIR are principles, are recommendations. Nice to speak in Christmas dinner. Like something that is very cool about data, and everybody dares, even if they don't have any clue about metadata, they dare to speak, oh, data should be findable, accessible, interoperable, reusable. What could be wrong if you do that? Fantastic, but how much it costs that? This is another big question. And another big question is how much it costs not to have data fair. So the first thing that I want to thank you about is that it was an amazing, and thank you to Peter for the very comprehensive and amazing presentation about data, kinds of data, types of data. But think about what kind of research data do you work with? Because it was very nice, the ice breaking this morning, because it gave me a clue who is in the room. What are you working with? Are you working with pictures of cultural heritage? What is your raw data? What is your insight for your research? Do you work with statistic data, which is the most common thing? Or do you work with paleographic documents? Do you work with ADN strings? All of these kind of things are data. But in each domain, they have an approach to be fair. Fair, there are general principles, but if you go to the domain, you have to approach precisely the metadata, the PIDs, and the particular vocabularies that can make your data valuable in your context. Unfortunately, science nowadays is very vertical. We make science in our own field. Physics, papers on physics, papers on physics, papers on medicine, and all my peers and all the system is in a silo, in a vertical silo. But Eureka, the discovery in science, comes between disciplines. We knew that when the COVID came. We need real-time science and multidisciplinary and interdisciplinary research. So how can we think out of the box, out of our own field? This is what we think about interoperability and the fairness of our data. Then our data can be reusable for other people out of my field out of my computer, out of my research team, which is the only people that can reuse my data. One of my favorite jokes is to grab some researcher and say, well, you are from economics. Just come here, look at a data set in Zenodo, and try to reuse it. No way, they don't know how to reuse it, even if they are data in their own field. The problem with the policies is that the policies are binary. Did you share your data, 0 or 1? Yes, I did. Oh, they are there in Zenodo. I put my data there. Can everybody use it? No. So the point is about being very conscious about what is the diversity of the data and how to make this useful. I will just run over these slides because you made a better classification about what are the research data types. But this is only just an approach because I remember once that I was discussing with one of my peers in the vice rectorship of policies, scientific policies, and she said to me, I'm a lawyer, I don't use data. And I said, well, if you do research in law, you use data. For you, the data are the legal agreements, the statistics that you get from your users, the data that you get from the judge. You have millions of data around you. It's not that you read a book on civil law and you are researching. No, that's reading. Researching is managing data. So this is a point that you have to be considered that everybody use data. But in the context of the new research policies, there are only 4 types of data. The data that they are the raw data, that means the underlying, probably dirty, not clean up data that they are coming out of our research. For example, if I'm researching with sensors, all the data that they are collected by default. And also we have the curated data that are those that they are already cleaned up, that you haven't established a structure or something like that. The data that you want to publish, cling, in Zenodo, you put a data there. And also the metadata, that they are the things that they make the data valuable. And sometimes you can publish the data without metadata. So you reach the tick of sharing data, but you don't have proper data. This is also more about the management of data cycle that was also covered fantastically by the presentation of Milena this morning. But why to do the research data management? Why to do data management plans? And want to become this data fair? So how many of you have done a data management plan? 1, 2, 3, 4. Yeah? Okay. So this is the way of thinking over what are your data about? What are your data going to be? And what do you want your data want when they grow up? No? That will be the best way to approach it. Sometimes you can do a data management plan, and it's a binary requirement. Did you do a data management plan? Yes, I did. Is that data management plan useful? Who knows? At the end, it's good if we have a mechanism of creating those data fair. And FAIR is what I said to you, that it stands for findable, accessible, interoperable, and reusable. Okay, good night. I can go to bed now. So you say that, and everybody can say that. But this is the meaning of that is why I have to create this data findable, accessible, interoperable, and reusable, and what does it mean, and who has to create it. For example, we have this discussion within our project. Should we train data stewards, that the data stewards are the people that they deal with data on purpose? In my own lab, I have a lab of 3-4 researchers and some doctoral students. I cannot afford to have a person that is a data steward in my lab. My university, I don't know if they can afford to have data stewards on top of data librarians, on top of who can afford to have a specific person, and also who is the best data steward, somebody that knows about their own data, and somebody that knows a lot about curation, fair data, and these kind of things. It is a balance sometimes who has to be the one. If we look at the principles, you can find this. This is from my previous project, Fair for Health, that we have this color and these acronyms and I1, I2, F2, F3. But those, if you look at the principles, it's more than findable, accessible, interoperable, reusable, and I can't go to bed night. This is going through, if you go to the principles, I will go through all of them quickly but deeply. They talk about metadata and they talk about PIDs. I have this joke with Barry Mons. Barry Mons is one of the guys that wrote the famous paper on FAIR principles, that you know that there are millions of authors. FAIR principles were created in Force 11 meeting in the United States in 2016, but it was written down in a paper for many authors. One of the authors is Barry Mons, and I have this joke with him that for me, FAIR principles is 80% of metadata standards and 20% of PIDs. And I say to him, we can negotiate the percentage if you want, but I will not go farther than that. So he put this slide on the conference of the Research Data Alliance in Philadelphia, and he was joking at me that he said that sometimes you have digital object also percentage, which is the digital object definition, is what really entails the 80% of the metadata and the 20% of the PIDs. So to legitimize this concept, that's what I have these all approaches to the what is metadata about, and to make data findable, accessible, interoperable, and reusable, you need go through all these metadata standards, metadata vocabularies, metadata for the data, and also having a standard catalog that provides you the right metadata. It's not that people imagine that in the context of publications, we people in general, they are trying to reproduce with the repositories, reproduce what they did with the publications in the 2010, now with the data. But imagine that a publication, it doesn't matter if it is a publication on the humanities, a publication in social sciences, or a publication in mathematics. They always have a title, an author, a number of pages, blah, blah, blah. This is what Dublin Core was about. Metadata describing a common thing. But if you think about in the data that you use in humanities, the data you use in economics, and the data that you use in astrophysics, they don't have anything in common. The properties, the values that they have, those metadata, are far more, and they need more granularity to be useful than saying this is the title, this is the this is a title, or this is the author of this collection of data. That's why when you mentioned this morning that the only two repositories that they are prepared to receive or to gather data and publications are HAL and the Austrian one. They are two repositories that they were created for publications. To create or to storage data there, it is more limited than storage the data in your own discipline data. What I said always is that the data should be what the community of that field thinks that the data should be, all together. And then you can have a national catalog, a metadata catalog, that's fine. But to deposit the data should be a disciplinary approach. That's my opinion in general, but it has been, there could be different specifications. So what is being fair? Being fair means to have your metadata and the data easy to find, both for humans and for computers. When you mention JSON and JSON-LD, which is the vocabularies that sometimes we use to encode this kind of linked data, JSON is readable by machines, but it's also understandable by humans. So that's a good way to think about encoding. And we have to have persistent identifiers, rich metadata. This is a huge discussion in my community. What is rich metadata? Okay, just rich metadata, a lot of metadata, precisely, standardized. What is the trade-off between very, very granularity, a huge granularity with the practicality of completing the data? That's the point. And also the metadata should be indexed and should be in a searchable database that we call it repository. The difference between a repository and a metadata catalog is that the metadata catalog only gathers the metadata. but the repository gathers also the data together. That's the point on this thing. So the first thing is that you have to assign a PID to your research data. Some of the theories and some of the millions of documents that you can look at about FAIR data, they say assign a DOI to your research data set. Okay, a DOI or another persistent identifier. For example, I have been discussing with Latin American community that they don't have time, they don't have money to maintain the DOI system, paying for the DOI for the data sets. So they are working heavily in ARC. ARC is another standard that makes completely available and persistent the data. That's it. It's not about DOIs. It's about persistent identifiers, where DOIs are the most common. Describe your data in a rich way. When rich means think about everything that is surrounding your data in your laboratory, whereas the variable, what is the data set dimension, what is the licensing, what is the time, etc. So I think I have 3 minutes to go through 25 slides. Good. It's not about the slides, it's about you to be aware of what is going on in the kingdom of the FAIR data. This is describing rich metadata, means also describing not in the granularity and all the properties that they have the data, but in a standardized way. So that's why I recommend always my students, my researchers, to use the metadata standards catalogs, because what I say about metadata is that metadata are like the toothbrush, you know? Everybody thinks that it's a very good idea, but nobody wants to use the other ones, you know? So that's the point about metadata. Everybody wants to create a new metadata standard. I have heard so many times. I remember once in the in the photon and neutron infrastructure, they told me, no, but you don't know about our field. Our field needs much more metadata. We have to create a new standard. And I say, no, don't create from scratch a new standard. Think about what the community already embraced, because it's easier to apply one that is already existing. Not creating the best is an enemy of the good. So what to do when you have to find a home for your data, when you have to find an index or a repository? There are several options in the very well-defined research fields. They know what they have to do. If you go to the United States and you work in life sciences, everybody knows that they have to put the data in Dryad. That's it. It's no negotiation. It's no discussion. If you work in neuroimaging in Europe, everybody knows that they have to put in Open Neuro. If you work in archaeology, you have to use the UK archive and data repository. So there is no discussion. But if you don't have a domain-specific repository, you can try to search for a specific repository in your field, or opt for the Zenodo option. I always say that Zenodo option is the repository for homeless data. When you don't have your proper repository in your field, or your institution doesn't have a repository, because sometimes what we are creating at university levels, for example, all the universities of Madrid, all the universities of the Netherlands, they have created engaged repositories using Dataverse software for the universities, for a group of universities. But this is for the long tail of science. If you are working in high-performing computing or data-intensive fields, it's better to use the repositories that you have in your field. Well, and also you have to use all these laboratory tools that they allow you to make and to improve the description of your data. If you have a notebook lab, you have to do it in your data. Okay, so this is just, the slides will be available. I think all the things that we have covered, the things that I said before is here in the slides. You have all the practicalities about how to make your data fair using different resources that I selected for you guys. And also think about that fair is many times a question of how much it costs to make those data fair. There is not a consistent study that says how much it costs to make your data fair, but there is a study that it was recover, it is a study from the 2019 from the Commission, how much it costs, don't make your data fair. That was now reflected in the French policy. And also we are extending the principles, for example, extending the fair principles to the indigenous data that was done by the Australian and New Zealander communities of the Australian Research Data Commons that they have been working on the care principles, and also the new approaches from the private industry, from the industry. They are embracing fair principles for the data, but they are also adding 3 new properties of extensibility, security, and trustworthiness. But these 3 properties, they are all again based on metadata, all the completeness of the metadata, security description, and have all these possibilities to be trusted in the information, that you protect personal issues, that you protect personal data, etc. And this is what Sarah was mentioned this morning about EOSC, so I will not go through the EOSC infrastructure. Just let me tell you what is the current landscape of EOSC. You can find out fields that they are data intensive, that they are the lead users. Then there are some scientific communities that they are getting well together. And then there is a long tail of science, which is where the repositories, the generic Zenodo, the open research framework, all these approaches is that they are generic, comes through, along with the citizen science data. All those data that they are produced in a very scattered way by citizens. So those are the things that we have to think about creating a new metadata layer. So I think this is all for my side today. We can just discuss more about fair data. I'm happy to help you to do your own approach in your field to your fairness. And thank you very much.